everyone, welcome to the new video. So today I am thinking to do a mock interview with ChatGPT on Terraform. So without further ado, let's go. So already I have given the that I have 5 years of experience and my with 4 years of relevant experience DevOps. So can we do a mock interview on Terraform? So it has started. So question one is, what is Terraform and how is it different from tools like Ansible or CloudFormation? So what I'll include, Terraform is a provisioning tool, and Ansible or Ansible is a configuration, or what you say, configuration management tool, or tool which will do configurations on servers post provisioning. Okay, and cloud formation is a infrastructure management service, but native to service but native to AWS, while Terraform supports multi cloud. And then Terraform has declarative approach. Okay, um, and Ansible has procedural approach. So, and we can say cloud formation also has, and we can, so like main pointers, but of course there will be a feedback coming because yeah, so I have to mention about state management, which I forgot to mention. Then Ansible is CloudFlare is similar to Terraform, that is also declarative, but it is a AWS. And the state management, I have state file I have to mention, so that it shows that how it tracks the um, from the actual infrastructure to the code that we have. So can you explain what the Terraform state file is and why is it important and how you manage it in a team? So Terraform state file is a file that tracks actual configuration or resources present in cloud with the code that we have. Okay, and before Terraform apply is done, um, state file is checked first. It keeps a track, and to avoid in multiple team if we have to manage, so to manage for team, we need to keep Terraform state file in central environment with proper lock and versioning enabled, and backups created with the minimum access to people. Okay, so I am giving like this, but of course there will be suggestions coming. Okay, centralized per team. So why state exists? Because it helps in state drift and everything. So Terraform say keeps a mapping between Terraform resource defined difference during plan, understand resource dependencies before running Terraform apply. Terraform compares the desired configuration with current state. So this is what I have missed, and I can improve my answers like this. So backend is and state locking. What is a Terraform backend, and can you explain remote backends and how state locking works? So remote backends are uh, basically where we to keep Terraform state file in a central location so that multiple teams can use same state file and keep tracks of the resources created by different teams. Okay, so it is kept in remote backend like AWS S3 or Azure Blob storage. Okay, remote backends we configure. And for state locking means that no two individuals can do changes simultaneously on same resource. Okay, so for state locking we use reference data or reference data service or database service like Dynamo uh, DB in AWS. Okay, so let's see what it says. Uh, so a Terraform backend defines where and how Terraform stores a state file. By default, Terraform uses a local backend, but in real world team we use remote backends. Fine. So that didn't explain. Remote backends store the state file at centralized locations such as AWS S3 or Azure Blob storage. A concurrent Terraform apply operation that could corrupt the state file. So, for example, when using S3 as a backend, Terraform integrates with DynamoDB to acquire a log before making changes. So, yeah, this is what is a real, or a polished answer. Now explain what happens internally when you run Terraform init, Terraform plan, and Terraform apply. So what Terraform init, it initializes plugins or providers, like whatever provider we have mentioned, if AWS or Azure, it will initialize everything. And then Terraform plan will compare the Terraform state file and show what changes we are doing, what and what deletion or addition of resources are happening. Uh, and then once we confirm, then in Terraform apply will apply the changes in actual infrastructure once we confirm. So this is what I have explained, but let's see what it says. What in the so backend initialization, module initial, how plan is in a refreshing state. So yeah, so Terraform init has to be explained, like how downloading and initializing provider plugin, initializing the configured backend modules using the configuration. This steps Terraform to run further commands. And then it reads the current state file, Terraform plan, refreshes the state by checking the real infrastructure, compares the desired configuration with the current state, generates an execution plan showing what resources will be created, updated, or destroyed. And then Terraform plan will reuse the execution plan, build a dependency graph, and create, update, or delete resources in the correct order. Okay, so this is what how I can polish my answer. Now it is asking Terraform state drift. What is a Terraform state drift and how do you detect it and how do you fix it? So Terraform state drift is uh, Terraform state drift is basically there are few resources uh, which exist, or there is, or we can say basically there are some resources um, which are not tracked by Terraform, or not mentioned in Terraform state file, and there is a huge uh, difference between what exists in actual infrastructure um, and what is present in our code, like what we expect, but it is not what is expected in our Terraform code. Okay, so how we detect it? We will detect it when we will have Terraform plan, or when we run Terraform plan. There will be some errors that will be coming. Okay, by running Terraform plan, we can detect the drift and how to fix it. So fixing is basically we need to do Terraform import, okay, of that particular resource. So this is how what I have given the answer. But yeah, what is the key difference? Terraform state drift occurs when the actual infrastructure differs from what is defined the Terraform state or configuration. So this usually happens when resources are modified, deleted, or created manually outside of Terraform, such as through the Cloud Console CLI. So Terraform detects drift during Terraform plan, where it refreshes the state by checking the real infrastructure and shows any unexpected changes. To fix the drift, we if the resource exists but is not in a Terraform state, we can use Terraform import. Then if a resource was deleted, Terraform will recreate it during apply. If the resource was modified manually, we can either update the Terraform code. So all the scenarios we have to capture. I didn't capture all the scenarios, but when you are giving the interview and you capture all the scenarios, that is a good answer. Okay, what are Terraform modules? Why do you we use them? And then how have you used modules in your project? So Terraform modules are like reusable block of code that we can use by passing the values of our variables, and they can be created outside our project. There are many, we can have custom modules or modules available publicly of AWS, okay, that we can define. Then why do you use them? We use them so that we don't have to repeat code for same thing again and again. This I am just giving in a very vague sentence, but and how like modules of AWS, okay, we have used, or custom module to create S3 bucket. So this you can give, and let's see what is the answer. Okay. Um Terraform are usual self-contained blocks and modules can be public, and we use modules to avoid code duplication. So this is a correct technical term that we should use. And AWS public modules. Now it is saying what type of variables are available in Terraform and how do you manage different environments like dev, QA, and prod. So there are command line where that we can give while giving the commands, while giving Terraform commands. So they have highest priority. Okay. Then we can give Terraform TF wars. Basically, to apply values of variables for different environments, we use separate Terraform.tf words, okay, for different environment like prod, QA, there, and then we have variables dot tf, but this have a low priority than a tf, um, terraform.tf was file. Okay. So this is how I've just given this. Let's see what it is giving. Declares value. Yeah, so there are corrections. Terraform supports multiple uh, command line environment variable, yeah, default values. So this is how we can give. Now sensitive data and secrets. So how do you handle sensitive values like password, tokens, or secrets in Terraform? So um, we will keep secrets in secret of GitHub repo, which is in settings, and then use, and also for cloud, we also for cloud secrets we use HashiCorp, Vault, or AWS Secret Manager, or Azure uh, Key Vault, proper masking of secrets in code is done, so that secrets are not exposed in logs. Okay. So this is what I have given, but we can give more. Let's see what we can add. We can add sensitive to actual secret state file, API token. So be very specific. I am giving very general answers, but we can go through these polished interview ready answers like sensitive values and password, token, API keys should never be hard coded. In CI, we store secrets secure in tools like GitHub Secret. For our cloud native, in Terraform, we mark sensitive variables. Sensitive is equal to true. So, and we also ensure proper access control on remote state backend. So, if a Terraform say can store sensitive data, how do you secure the state file in production? Files can store sensitive data. How do you secure the state file in production? So for production, we need to restrict the access. Nobody can access the state file directly. Then of course we should use in state file, avoid passing secrets. Okay, and then proper services, secret storage services, secret storage services should be used. So I have given like this, but let's see. So this is a very important question. Last question. You have a Terraform project where multiple teams are working on different parts of the infrastructure. How do you avoid conflicts and manage dependencies between teams? So I've already given my answer, but there are corrections which are needed. So in this, each team manages its own Terraform projects and its own state file, typically stored in a remote backend. This ensures isolation prevents accidental changes across stream, and shared infrastructure components such as VPC or networking are managed in a separate Terraform project. Other teams consume their resources using output and Terraform remote state data sources. State logging is enabled, IAM access control. For environment separation like dev, queue, and prod, we either use separate state backends or Terraform workspaces, though in production setup, separate backends per environment are generally preferred. So this will tell, this is a very great example, or what you say, question that can be asked for checking the real world Terraform architecture knowledge. So yeah, that.